So we previously looked at determining the different kinds of properties of matter as far as whether they're physical or chemical. And now we're going to look at what happens whenever we actually have changes in matter that occur. And determining whether it's a physical change or a chemical change really uses the same kind of thought process, because a physical change is simply a change in matter that alters a substance without changing its identity, without changing its composition. So we could change its state, for instance. We could change it from a solid to a liquid to a gas. Changing its state of matter doesn't change the identity. We don't change water molecules simply by freezing them or melting them or boiling them. They're still water molecules. We just change how fast they move and how far apart they are is pretty much all we do. If we chop up something or grind up something or cut it into little pieces, we haven't changed the identity, for instance, of a piece of paper or a log, a piece of wood. By doing that, we've simply made it into smaller pieces. We haven't changed its identity. We've already established that dissolving something in water does not change its identity. It just makes it smaller, the smaller particles that we can't see because the water gets in the way. So all of those are examples of physical changes. And it doesn't matter what we do. Sometimes people get confused and they'll say something like changing alcohol from a solid to a liquid, or from a liquid to a gas, evaporation of alcohol, or sublimation of iodine crystals. As soon as you mention one of our phase changes, a phase change is a physical change. So phase change equals physical change. So you can look back in the previous notes to see those phase changes, and if those words are used, it doesn't matter what comes after it, no matter how chemical sounding it is, it's still simply a change of state, going from a solid to a liquid to a gas or back. Chemical changes, there are some clue words that you can find in chemical changes, because a chemical change is a change that does change the composition. It changes the molecules themselves. Burning something is going to change it. Cooking, decaying, fermenting, tarnishing is another example. Rusting. All of these are examples of changes that occur that change the composition. Rusting, as I said before, digesting something. One of the ways you can look at a chemical change is, can you get back easily what you started with? If you burn something, if you burn a piece of paper, can you get back what you started with? No, chemical change. If you cook something, can you get a raw egg back from a cooked egg? No. And although if you digest food, you could get it back again, I don't think it'd be in quite the state it was to begin with. So those are simply examples of changes in matter that change the composition. So those are the kind of things you're going to look at when you do the worksheet that involves those physical and chemical, determining whether there are physical or chemical changes. And there's a worksheet about that in your packet. Now, as far as indications of chemical change, how do we know that a chemical change has occurred? There are different things that we can look for whenever we're observing changes and decide if one of those has occurred, and that it's going to indicate that a chemical change, an actual change in identity, has occurred. One of these is change in color. Production of light is another example of something that shows us that an actual change in identity, a chemical change, has occurred. So production of light. Change in temperature, when you haven't added anything, added any heat to the system or artificially put it into a refrigerator or something. A change in temperature is often an indication that a chemical change has occurred. Production of a gas that bubbles and fizzes. is a chemical change, production of a gas. So bubbling, fizzing, those are indications. And we're going to be looking at those in the lab when y'all get into my class when the school year starts. Production of a precipitate. If you mix two clear solutions together and you get a resulting mixture that looks really cloudy, then you've formed a precipitate. And as it says down here, a precipitate is simply a solid that's formed during a chemical reaction. If you let it sit long enough, then that would sink to the bottom and you could see it more clearly that it was actually a solid. But at first it simply looks like it's just really cloudy. It may be white, it may be a variety of different colors. Finally, a change in smell is a good indication that you have produced a change in that material. It's changed the identity of the material. One thing that I do want to point out before we go on, though, is the law of conservation of mass and the law of conservation of energies, because it's going to be important to realize that whenever we do any of our chemical reactions, we're not going to create or destroy anything. In any chemical or physical process, matter and energy, you don't create or destroy either one of those. With matter, you simply rearrange particles, you rearrange atoms, and create new kinds of combinations. But you don't create new atoms, you don't destroy atoms. As far as energy is concerned, you don't create or destroy energy either. It can change from one form to another, whether it's from electrical to mechanical or from light to chemical. You can change the form, but you can't create or destroy it. So that's an important thing to realize as well.